We are now on case 3, non-repeated quadratic factors. Now we associate the partial fraction into a times 2ax plus b all over ax squared plus bx plus c, wherein the coefficient of the first term of the numerator is equal to the derivative of the quadratic factor, ax squared plus bx. So the derivative is 2ax plus b. Example, 1 over x times x squared plus 3x plus 4. As you can see, the first factor is a linear factor, so that's why we have a over x, but the second factor is a quadratic factor. Now, when we say quadratic factor, it is not factorable, no, anymore to linear factor. Kasi if it is still factorable to linear factor, then it is not quadratic factor because it is still factorable to linear form. So if it is not factorable to linear factor, then we will consider this as quadratic factor. So that's why on our second term we have b times the derivative. Remember, no, the first term has the derivative. The first term is multiplied by the derivative of the quadratic factor. So plus b times the derivative of x squared plus 3x, which is 2x plus 3, plus c, then all over the quadratic factor. Also, if we have 2x squared minus 1 all over x squared plus 1 times x squared plus 4, since these two factors, no, are not factorable into linear form, then we will consider these two factors as quadratic factors. So the first factor is x squared plus 1, so that's why the partial fraction is a times the derivative of x squared plus 1, which is 2x, plus b, then all over the quadratic factor, plus the second term, which is c times the derivative of the second quadratic factor, which is 2x, plus d all over x squared plus 4. Also, if we have x minus 5 all over x to the 4th plus x cubed plus 2x squared, first we factor out x squared since it is common, no, in the denominator. So we have x squared plus x plus 2. Now, as you observe, we have linear factor x, but it is repeated twice. That's why we have a over x plus b over x squared. However, the second factor is a quadratic factor, which is not factorable, no, to linear form. Then we will apply now the partial fraction for case 3, which is c times the derivative of the quadratic factor, which is 2x plus 1, plus d all over x squared plus x plus 2. So let's have an example. Find the integral of 8x squared minus x plus 8 all over x times x squared plus 4 dx. So first, we will observe the factors in the denominator. So we have x, which is linear, x squared plus 4. It is not factorable, no, to linear form, meaning it is a quadratic factor. So we associate the partial fraction into a over the first factor, which is linear, a over x, plus the second factor is quadratic, so b times the derivative, which is 2x, plus c, then all over x squared plus 4. Then our goal now is to solve for a, b, and c. So to solve for the unknown values, first we will eliminate the denominator, and that is done by, again, multiplying the whole equation by its LCD. So the LCD is x times x squared plus 4. So multiply, we have 8x squared minus x plus 8 equals a times x squared plus 4 plus multiply, we have x times 2bx plus c. Then distributing x on the second term, we have 2 bx squared plus cx. Then applying the vanishing factors, let x equals 0, since if x is 0, so these two terms now vanished, so we can now solve for a. So if x is 0, we have 0, 0, 8, 4a, 0, 0. So meaning a equals 8 over 4, 2. Then assign any value of x to solve for other unknown variables. Let's say x equals 1. Pinakamababa, no? Para mas madaling ma-evaluate. 1, so 8 minus 1 plus 8. So 1 plus 4, 5 times a. A is 2, so 10 plus x is 1, so 2b plus c times 1, since x is 1, so plus c. So we have 8 minus 1 is 7 plus 8, 15, then minus 10. So we have 2b plus c equals minus 10. 7 plus 8 is 15, then minus 10, we have 5. So equation 1. Then for x equals, let's say, negative 1. So negative 1, still 8. Negative 1 times negative 1 is positive 1. 8 plus 8 equals, so this is 5 again, times 2, 10. Then x is negative 1, so positive 1, so positive 2b. Then this is negative 1, so minus c. So we have 2b minus c equals, so this is 8, 9, 17 minus 10, so 7. So equation 2. Now using equation 1 and 2, solve for b and c. So to solve for b and c, so we add equation 1 and 2 to solve for or to eliminate c, since c have or their signs are opposite. So we add, so that is equal to 0. So equation 1 plus equation 2. So 2b plus c equals 5, then plus 2b minus c equals 7. So for b 0, we have 12. So b equals 3. Then solving for C, so we substitute no b equals 3 to either equation 1 or equation 2. So solving for C, we have using or at equation 2, using equation 1, 2b plus c equals 5, b is 3, so c equals 5 minus 6, or c equals negative 1. Therefore, a is 2, b is 3, and c is negative 1. So we can now write the given integrand in its partial fraction form, which is a over x. A is 2, so 2 over x, plus b, which is 3, so 3 times 2x, plus c, which is negative 1 or minus 1. Then all over x squared plus 4 dx. Then upon simplifying, we have 2 over x plus 6x minus 1, then all over x squared plus 4 dx, which can also be written as integral of 2 dx over x, then plus 6 integral of x dx over x squared plus 4, then minus integral of dx over x squared plus 4. Since we divide each term of the numerator on the second term by x squared plus 4. So 6x over x squared plus 4 minus 1 over x squared plus 4. Then upon integration, we have 2 ln x plus 6. U is x squared plus 4, du is 2x dx. So du is 2x dx, meaning the balancing factor is 1/2. Then minus, we have a squared equals 4. So a is 2. U squared is x squared, meaning u is x. If u is x, du equals dx. So meaning this is integral of du over a squared plus u squared. Remember the formula for du over a squared plus u squared is equal to 1 over a arc tan u over a plus c. So this can be evaluated using the formula 1 over a arc tan u over a plus c. So since du equals dx, so we integrate by the formula for du over a squared plus u squared. So we have the Final answer, 2 ln x plus 6 over 2. So that is 3 ln of x squared plus 4. Then plus or minus, this is 1 over a. So 1 over a, 2. So 1 half arctan u over a. So x over 2 plus c. So the answer for the given integral is 2 ln of x plus 3 ln of x squared plus 4 minus 1 half arctan x over 2 plus c.